Howdy, this is the final video for the week, and it's a look at simultaneous quadratic and linear equations. It's one of those things that creep into the course where it's not part of the official documentation, but you could be examined on it. They creep into the exam, so it's worth having a look at them not. So I wanted to show you graphically what a simultaneous quadratic and linear equation looks like with it really is the same concept as finding the point of intersection of two straight lines. But when I put in a quadratic parabola like so, then when I draw a straight line through it, I could have up to two solutions. So here's one straight line. I'll draw it in red so it's different. And as you can see, there's one point of intersection and 2 points of intersection there. So when we solve simultaneous quadratic plus linear, we could end up with two possible solutions rather than just the one. I say two possible solutions because other things may occur. So, for example, if I have a parabola that's here, for example, this is the bit that's tricky to draw. My straight line could, I just missed there, but I hope you see what I mean. It sort of just kisses the graph and then keeps going. There's an official name for it. It's called a tangent line. So that's only got 1 point of intersection. It touches the graph at 1 point and then goes. And then finally, we could have a situation where we've got a parabola and the straight line just never hits it at all. So that's no solutions. So we could have two solutions, one solution, or no solutions whatsoever. And we're going to do an example of each. So I'm going to zoom out now and take you to the example screen, and we've got three examples to have a look at. I won't sketch the graphs. I don't need to. It's just some examples so you can sort of get a sense of it. So here we have two equations. One's a quadratic and one's a linear. So I'll label them 1 and 2, but I don't really need to worry about the labeling for this particular example because almost always they're written like this, where y equals something like the quadratic, and then the other one's y equals in some sort of linear expression. If they're not, you can always rearrange them so they look like this, because then the next step is to simply use the substitution method. If y equals this and y equals this, then this must equal this at the points of intersection if they exist. So the solution is to simply go x squared. I know that I'm going to be pushed for room here, so I'm just going to go a little bit closer. X squared minus 8x plus 12 must be the same as minus 2x plus 4 for points of intersection. And now I'm just going to simplify it I'm going to do two things at once. I'm going to add 2x to both sides, and I'm going to subtract 4 to both sides. So when I add 2x to both sides, the negative 2x, it disappears, and I'm left with minus 6x. And when I take away 4 from this side, that goes, and I take away 4 from the 12, and I get 8 is equal to 0. And now I have to factorize that. It will find the solutions really in any way, shape, or form. So it could be by factorizing, it could be by completing the square, it could be by quadratic formula if I have to. Because I prepared this in advance, I already know that it can be factorized fairly easily, but pause the video. It is a trinomial factorization, so pause the video and see if you can come up with the values for x. Okay, you're back, I hope. Or if you're not back, then you're not listening to this, so that'd be silly, wouldn't it? But I can see here that for plus 8, 4 times 2 is 8, 4 plus 2 is 6. I've got a negative here, so it's negative 4 times negative 2 will give me what I'm looking for. So it's x minus 4, x minus 2 equal to 0. So that's it. That's factorized. And by the null factor law, I can say that x is equal to 4 or x is equal to 2. Okay, and that's the null factor law. Okay, remember that points of intersection or any simultaneous equation solving requires you to not only find the x values, but also the y values. So it's always two sets of values. So I'll just put it into this little section here. So I'll go, I'll pick the easier of the two equations, of course. So in equation 2, for x equal to 4, I would have y equal to -2 times 4 plus 4, which would give me -8 plus 4, which is -4. Okay, so when x equals 4, y equals -4. And what I like to do is I like to put the solution pair off to the side there, so 4 comma -4. And when x equals 2, I have y equals -2 multiplied by 2 plus 4. -2 times 2 is -4 plus 4 is 0. So my other solution pair is 2 comma 0. And that's my equations. Now, just for proof of purchase, here it is in Desmos here. We've got y equals x squared minus 8x plus 12 and y equals 2x plus 4. And you can see the points of intersection here are 2, 0, and then here 4, -4, just like my solutions were here. Okay, the next example is when there's one solution. It's the same process though. So I've got equation 1 and equation 2, and I set them equal to each other. Sometimes I do this, 1 equals 2, like that. So I write down x squared minus 3x plus 2 equals 1 minus x. My operations to get 0 on the right-hand side, I need to subtract 1, and I also need to add x. So that gives me x squared. I'm adding x, so minus 3x plus x is minus 2x, and 2 minus 1 is equal to 1, and that's equal to 0. And now I need to solve for x, so pause the video and have a go yourself. Okay, so how did you go with that? Did you get x equal to 1 and that's the only solution? I hope so. Did you do it this way though? Did you notice that this is a square, that 1 is a square, and I've got 2 times 1 times x in the middle? So it is a perfect square. So you can go directly from x squared minus 2x plus 1 to x minus 1 all squared is equal to 0. We call this a double zero because it's a repeated factor. It's x minus 1 times x minus 1, and it gives us just the one solution of x equal to 1. And then we can substitute in the easiest one, which is y equals 1 minus x. So in equation 2, x equals 1, and we get y equals 1 minus 1, which equals 0. So we've got a solution of 1 comma 0. So that's one solution. And again, over in the graph here, you can see there's the parabola, there's the straight line, and it's just kissing at 1, 0, and otherwise does not touch the graph. So just one solution. Last example over on slide 19 down there. Same process again. Label the equations, set 1 equal to 2, and we have x squared plus 2x plus 5 equals x plus 1. We're going to subtract x, we're going to subtract 1. Hopefully this is all routine for you now, so I'm just sort of going faster than I normally would do. So 2x minus x is x, and 5 minus 1 is equal to 4 is equal to 0, like so. We would go through, we'll go through our different kinds of techniques for solving. So pause the video and have a go yourself. Okay, if you were successful, then you would have found no solutions whatsoever. But let me take you through the process very quickly. Number one, is it a perfect square or a difference of two squares? No, it is not. Can I factorize it using trinomial factorization? I can't think of two numbers that I can multiply together to give me 4 that will add together to give me 1, so that doesn't work. So I've either got to use the quadratic formula or completing the square. And honestly, the numbers are so small, completing the square might be the best way to go. But you could absolutely do it using the quadratic formula. So I'll do my usual technique of going x plus half the middle term coefficient. Middle term coefficient is 1, so it's x plus a half squared. Then I have to subtract a half squared, which is a quarter, by the way. Half times a half is a quarter. And then I'm adding 4 to get 0. Now, at this point, you know, you don't actually have to write this, but this bit here, I can see is going to be a positive value, right? 4 minus a quarter. As soon as this bit's positive, then I know there's going to be no solutions. And if you can't remember why, go back to the completing the square videos and have a look. If this bit is positive, I'm not going to be able to take the square root of it when I switch it over to the other side. So I can just say, therefore, no solutions exist. and then I'm done. Okay, now again, I'll just show you the graph here. Here's the parabola, here's the straight line, and never the graphs shall meet. So that's why there are no solutions. Okay, I'll leave that there. Have a crack at doing some yourself, and that should wrap up the week for you.